Hey everyone, welcome to another AI conversation. I'm very happy to have today Simon Schultz. Actually, Simon and I were supposed to talk way back, and I'm certainly happy that we're finally having it. So, welcome to the show, Simon. Nice to have you.
Thank you very much. Very nice to talk to you.
Yeah. So, before we get into the weeds of it, we have a lot of interesting topics to talk about. For maybe the one or two people haven't met you yet, maybe give a brief background of what keeps you busy and what do you do.
So I'm professor of neurotechnology at Imperial College London. What does that mean? It basically sort of means I work at the interface of neuroscience, the study of the brain and engineering. I run a neuroscience lab in an engineering department, which means we do experiments on mouse brain mostly. We sort of develop new kinds of approaches to study it using sort of optical principles, information technology principles, etc. Um, and I guess sort of really what gets me out of bed in the morning is trying to understand how the brain works. And to do that, I've got to sort of develop, new tools. So that's what I do. I mean, I came to it from a very sort of circuitous path, if you like, as everyone takes a circuitous path through life. I mean, I started off studying electrical engineering and physics as
Oh,
an
wow.
undergraduate.
Okay.
Um, first at Monash University. Um, did a master's degree at Sydney Uni where I was designing
Australia.
chips.
Yeah.
And basically, I was implementing sort of neural network algorithms, artificial neural network algorithms on chips, but looking at the neuroscience literature to try and sort of make them more biologically realistic. And I went over to the medical school and sat in on the undergraduate medical science neuroscience course, and I got hooked on neuroscience at that point. And I sort of rethinking, do I want to be an engineer or do I want to be a scientist in a sense? I sort of fell on the science side, and I applied for scholarships to go over to Oxford at that time. I got one, and I went over to start a PhD in computational neuroscience in Oxford. Um, as a computational neuroscientist, I kind of felt I was very dependent upon other people doing experiments,
Mm.
like to yield the data, and I felt I wanted to be part of like asking the questions. Um, so I learned some experimental neuroscience sort of methods as a postdoc. I went over to New York for 4 years, was working there in the laboratory of Tony Movshon, came back to London
Right.
for a bit over a year to learn new optical techniques in the lab of Michael Heuser. And then I got the job at Imperial in 2004, I think it was, and set up my own group, bringing that all together really. So it all, at least in retrospect, it all kind of works. But I think, yeah, probably everyone can say that.
That's an amazing background. And as I was saying, we were talking offline before the call started. Neuroscience, neurotech, this is stuff that's not it's not mainstream in the Philippines and for many of our
Sure.
listeners.
Yeah.
So,
Yep.
but it's interesting that you came by it from the tech side first, and then you went into
Yeah.
the
Yeah.
neuroscience
No, no,
first.
sure. Yep.
So I guess
Yep.
I think one of the most obvious questions I wanted to ask, we keep hearing from computer scientists about how artificial neural networks were
Yep.
supposedly modeled after the real brain. So can you
Yep.
finally settle that myth or debate? How much of it is
Well,
really based on the brain and how much
yeah.
of it is not, right?
I mean, they kind of are, but in a very crude and simple way, right? I mean, um, sort of what we called neural networks, sort of back in the early 90s, I guess, were fairly simple at that point. Obviously, they've got much more complicated since, in terms of the recent machine learning architectures, but I don't think much has fundamentally changed, really. They've got bigger, etc., scaled up new tricks, but the basics were there. And the basics of a very crude model of a neuron, learning rules which are probably not actually that biologically plausible, but maybe they approximate things
Right.
indirectly that are. So um, I don't think we need to get too hung up on the fact that the actual neurons are not that realistic. I'm not sure that that matters very much. I think
Hmm.
what's being missed maybe is actually more the big picture architecture of the brain. you know
Hmm.
how how do our memory systems work? If you think about how we learn, I mean how we experience, what we do is we experience we have experiences. We basically over time we sort of turn experience into gist and ultimately to sort of semantic information. We pull the meaning out of it.
Right.
As an engineer, I think of this as a bit like a
Yes.
compression algorithm, right? We're sort of throwing away some bits, and maybe we can reconstruct, a memory if we need to, but we're sort of throwing away information. And I think we do this, through dreaming. I mean, we still don't understand all of the neuroscience here. There's interesting things involving a part of the brain called the hippocampus, how it
Mhm.
sort of interacts with the neocortex, sort of another part of the brain, and um, really there is this. So there's all of these things that we're uncovering in neuroscience now about how we basically turn our experiences into more abstract information that we can then use, that I think basically are not being dealt with at the moment by the AI community, or not in a useful way. They
Yeah.
haven't sort of digested that yet. So my feeling is that if we can kind of well, actually, what I would say is I think they're going to run into a brick wall at some point, and they're going to
Under the
come back
current
to neuroscience
trajectory,
and
right?
say,
Yeah.
"So how does it all work?"
Yeah.
Yeah,
I don't know. Obviously, I'm not into the neuroscience field, and my usage of AI is primarily from my work in the private sector.
sure,
So,
yeah,
I'd love to hear your take about. So one of the biggest transitions, at least for me, is moving on from simple machine learning,
yep,
regression analysis, for
yep,
example, which is quite fairly useful still
yep.
in many
Yeah, there's a lot of useful
research.
things for sure. Yeah,
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 and then transitioning to kind of like a neural network, which
yep,
at its fundamental unit is literally many of these regression
yeah,
type
yeah, yeah,
calculations.
exactly. Function
But
approximation
yeah,
algorithm, really, in the end.
but
Yeah,
then in aggregate, and maybe this alludes to your early point about abstraction. In aggregate, the thing can figure out handwriting. The thing can figure out
yep,
what a
yeah,
cat
yeah,
or a dog is, but it no longer, or does it conceptually, works the same way as a like a linear regression where
yeah,
each variable contributes to an outcome. That's actually happening at a micro level, but in aggregate, I guess part of it is it works, but no one knows exactly how. No
yeah. And
one
I guess
interpret
what
it.
is it? Is it really figuring out
Yes,
the concept of cat and dog, or is it trained to do a classification between cats and dogs? You
right.
know, are they the same thing? I'd say we do a little bit more than that. To be honest, we've got a more
Of
deeper
course.
understanding of what a cat and a dog is than arguably current LLMs, etc., do. But of
Yeah.
course, we don't really understand how they work, so it's hard to say. Yeah,
But as a neuroscientist, neurotechnologist, does your gut tell you? I mean, I'm not talking about any quantification here,
yeah,
or maybe you can shed some light.
yeah,
Is that closer or right in the same kind of trajectory to understanding how the real brain works? Because
yeah.
the real doesn't have these variables and and
Sure.
these weights.
I I don't think so. I
Okay.
think what we've done is we've come up with very clever, very big, sort of like black box fitting algorithms that you feed the inputs in and it will predict the outputs, right?
Yeah.
Um, and I've got a example of why I think this can't work. I think it's provably impossible, for instance, for us to get to artificial general intelligence
Using this
via this
framework.
approach,
Yeah.
as opposed to doing some useful things, which
Mm,
we definitely can do, right?
yeah.
But so basically, if you think about taking a brain, okay, and you're feeding it inputs and you're observing its outputs, and you've got like an AI model of, it doesn't matter what kind, but many billions of parameters or whatever. Now, how long would you have to measure the inputs and outputs of your experimental brain to be able to fit the parameters of this model?
Yeah.
And the answer is probably like the lifetime of the universe, right?
Yeah.
Because it's explosion of parameters. So it's an NP. It's what in computer science is called an NP hard problem, right? It
Right.
just explodes. You can't do it. So okay, slightly better problem maybe. Um, you're not observing one brain. You're observing 6 billion, 8 billion of them,
Mm,
or whatever. Yeah, you've got a planet's worth of people generating outputs, we'll call it the internet, um, and you're observing that. But actually, it's still the same problem. It still doesn't scale well. I think you still
Exactly.
have to
Yeah.
record for an ordinarily long sort of period of time, to be able to work. Now, you can asymptote towards something that might look okay
Yeah.
if you
Approximates.
don't probe too deeply.
Yeah.
And I think that's where we are now. We've got something that looks slightly better than ELISA from the 1950s,
Hmm.
but it's but you probe it and yeah, it's not that deep, So I my feeling is that that's a kind of fundamental problem with our current approaches. Now, if you think about it further, like how, maybe you can just scale further, maybe we'll get good enough, but actually we've already exhausted the data set, haven't we? The
Yeah.
internet.
Everything on the internet.
Maybe we can multiply the amount of data by 10. We're not, but yeah, to be honest, I don't think we can at this point because most of the stuff we're feeding into it is coming from it, so it doesn't count, right? So yeah, so I think we've saturated the data. So scaling is dead. So AI by scaling is now dead, pretty much, and that's acknowledged, I think, by many people in the AI industry, and they're sort of having these workarounds like agent models, etc. But I think that problem, the NP hard problem, is a fundamental one.
Yeah.
And so basically, I think a lot of people now acknowledge that this is, that there is this problem. But whenever you look at kind of the solutions, it ends to my eye basically, and then some magic will happen. So,
There's still a big leap that
so
needs to happen, right?
yeah, so that's why I'm a bit of a skeptic. Now, having said that, I'm really just not um up to date with more than the coarse details of sort of the current AI architectures. So
Right. Right.
maybe there's something I'm missing.
Yeah.
I completely can see that.
Yeah.
But that's just my fundamental gut viewpoint that I think we're not really, we're basically just doing a large parameter sort of model fit on data which was generated by brains. We're not going to get to AGI that way. We will get to a bunch of useful things, which we're
Yeah.
already
There'll
doing.
be a lot of useful tools, but
Yeah,
not
exactly.
necessarily
So
natural
that's
language.
fine. It's still probably worth doing. Whether it's worth like, burning the energy resources of our planet to do it is another question.
That's another question, right?
you know?
And we can touch on that later when we start talking
Yeah,
about ethics,
exactly.
right?
Yeah.
Okay, but I want to dwell on this a little bit, and again,
Yeah.
I might not be articulating it properly, but so let's just do these quick jumps. We had these
Yep.
fairly simple machine learning where everything is kind of like a linear relationship. That
Yep.
was straightforward.
Yeah.
Then
Yeah.
we go
Yep.
into this neural network thing, which is many, many, many of these little
Yeah. And they've
linear
got little
units.
non-linearities in them, so
Yeah,
it
but
starts
somehow
to.
it understands handwriting.
Yeah.
And then
Yeah.
now we've jumped into you mentioned compression earlier,
Yep.
this era of autoencoders and
Yeah.
transformers.
Yeah. Yep.
And what they're essentially, and again, this is me or maybe oversimplifying, essentially modeling sequences of stuff,
Yep.
right? Sequences of
Yep.
tokens, sequences of
Yeah. Yeah.
words.
Yep. Yeah. Yep.
But in so doing, it starts to look intelligent. It starts to look like it can converse with you. It starts to look like
Yeah.
it can
Yeah.
draw.
It
Um,
it it, it
I mean, what's
starts
your
to look
impression
like
on
that.
that? Does that make even any sense? Like, or are we
Well,
just fooling ourselves
okay. But
looking at
firstly, I would say our brains have evolved to basically anthropomorphize things, right?
everything, right? Yeah.
Exactly. We look at like movements of stars and natural phenomena, and we ascribe, as I mean, even in modern era to some extent, but I mean, obviously historically, very much so. And we ascribe intention to them, don't we? I mean, we've evolved to find these forms of meaning, and I think of course, we're going to do that in these LLMs. So yes, they start to look intelligent to us, but obviously, as you've seen many examples of, you can probe them and break the intelligent behavior very easily.
Right.
There are fundamental problems like the hallucination aspect of pretty much all generative models that we haven't got a solution for. And as far as I can see, the solution, I mean, the solution that's being used mostly is to have people checking the output
And we're back to
training,
like
and that doesn't
20th
scale
century
either.
stuff. Yeah.
Yeah, exactly. So yeah, I don't know. I'm a
Yeah,
skeptic.
I don't know what the next leap would be where we start fooling ourselves even better. I mean, it sounds like that's how it works, right?
Yeah, I mean, and this is an argument. I mean, some people basically say, well, if you can start to fool everyone well enough, that's the same as the real thing.
Right.
Um, I mean, I would agree with that at the sort of the asymptotic limit, but I'm not sure I agree with that at the level we're going to get to.
Yeah,
So yeah,
and I
yeah,
wonder though, and again, this
yeah,
starts to become philosophical.
yeah. It does.
Um,
Yeah,
at some point,
yeah,
the utility ends, and it's all just fun and games. I mean,
yeah, yeah,
for example, now art is being threatened. That's one area where I'm looking
mm,
deeply into. I'm not an artist, but I'm wondering. I mean, the artists freaked out about the camera when it appeared.
yeah, yeah. Sure. And then they started using it. Yeah,
And
exactly.
then they invented
Um,
new art. So fine, we get over
yeah,
that.
yeah. No, that's
Eventually,
right.
took a century,
Yeah,
but yeah, we got
yeah,
got over that.
yeah.
And then now, AI models are drawing art
But
better than any other.
let's face it, back before the AI models, it was quite possible and done on many occasions to take, you know, a paintbrush and a paint and copy things, do things in the style of other, and that was considered theft, right?
Yep.
um, and now it's the same. In a way, I think the problems are actually the ethical ones that are coming up as to who
Yeah.
owns the data, etc., as opposed to the practical ones, which in a way were always there. It's just the medium has changed a bit.
Yeah. No, it's good you
Yeah,
brought up ethics because where I was headed with that is for the longest time we've seen AI more as a again utility, productivity, let's do
yeah,
things faster.
yeah,
But now
yeah,
it's attacking, and these are the top four sectors that I'm pretty curious about, or three. One is the creativity
yep,
sectors, writing
yeah,
and
yeah,
art.
yeah, yeah,
Of course, education is being
yep,
disrupted.
yep.
All these students suddenly writing perfect essays and stuff.
Yeah,
And
exactly.
then journalism is
Unmarkable perfect essays, exactly.
and then related to that, it's journalism. You can write any piece of news. Now you can
Yep,
create any photo or
yep,
video to accompany it, and then you're
yep,
swaying
yep,
democracies right and left. So just
yep,
on those three alone, you've got
yep,
art, you've got knowledge, and you've got
yep,
truth,
yep,
seemingly at the mercy of AI. So
yeah,
that's why I'm wondering, what's the next leap if this thing's already
yeah,
wrecking some of the fundamental social fabrics, if you can call it that. And it's primarily math in very creative ways, using math in a
yeah,
very
yeah,
creative way. Where
yep.
do we go from there? Are we letting go of these fundamental things, or
Yeah, I mean, I think I mean, the the point I would make is none of the things that you talk about weren't possible before. They're made a lot easier, right? And I think it just sort of really highlights the need to establish the ethical and regulatory frameworks that our societies are based on, um, to sort of bring these things in. Because before, in a sense, we didn't have to worry quite so much because they weren't that easy to do, right?
yeah, it was a
Um,
natural
and
barrier, right?
exactly, but now, but now there isn't, and so, and all of these things like who owns the data. I mean, and this is where I think there's just a fundamental facing off, which is starting to occur. The novelists, basically, fiction writers. I've noticed that there's a bunch. They're all up in arms and protesting against sort of various AI companies having discovered that their books have
Have been ingested.
unbeknownst to them, being used in training data sets, and you can basically pull out details of their books. And they never gave permission for that. Uh, and we now have companies that have, you know, market capital greater than many countries that are leaning on countries to modify their intellectual property laws
Yeah,
to make that okay,
that's happening. Yeah,
right?
right.
So that's actually a serious thing that we need to think about worldwide, to be honest. Um, yeah, is it okay? Now, these companies have clearly got a vested interest in the answer to that going one way. Is that the right way? My feeling is probably not, that we have to at least have some kind of sort of data ownership, or at least for a time, sort of tracking it. That yeah, which won't be what these companies want. So I think there's probably going to be a bit of a fight coming up between various sort of government regulatory, and there already is. I mean, you've
Yeah,
got Meta sort of squaring off against various countries, and
yeah. They're doing it's
well,
company versus
yeah,
governments now. It's
yeah,
amazing.
yeah, yeah.
It
And it's
really.
not clear who's going to win, to be honest. It's yeah, yeah,
Yeah, but okay.
yeah,
Let's now dive into the ethics part. Just
Yeah, yeah,
um, is there anything from your exposure to neuroscience
yeah.
that can serve as a good, I don't know, analogy or as a good basis for how we can
I
approach
think there is
this?
actually. Yeah, I mean, I would say in general with neurotech, sort of my area, I think we're tracking behind AI in terms of people thinking about it, but all of these things are up there and being discussed at the moment. Um, I'll maybe want to come back later to actually it's already starting to influence uh,
Neurotech
regulation and legislature.
regulation. Yeah.
Um, but I think in more broad medical ethics, actually there is um, a lot more that's been done. I mean, in particular by countries that have got national health systems. And I'm most familiar with UK and Australia. I think Canada has got something similar.
Mm.
I'm not really sure how to what extent this is the case in the Philippines, where the Philippines sort of follows more the US model in this, where it much more is privatized in a sense.
Yeah.
And I think the NHS model, like there is much more regulatory oversight of ownership of health data and all of this kind of thing, right? Um, you can't just accidentally sign away your data to your insurance company, and it's and there's a lot of thought goes in. There's this sort of nice agency at NICE, it's called a regulatory agency for all new devices and including things that sort of use data, um, and so basically, there's a lot of thought has gone into the protection of that data. Now, they are prepared in the UK NHS anyway to give that out in some cases to private companies. And that's not been without issue. For instance, the US company Palantir has a contract to do some things with UK NHS data, which I'm
Wow.
personally not
Weren't like they
not a big
like
fan of.
Cambridge Analytica before Cambridge Analytica?
And Cambridge Analytica before that, exactly. So basically there are already warnings, but I think thankfully they are, of course, actually
Yeah.
bringing up red flags in regulatory bodies who are thinking about all of these things. Um, Now I'm actually involved with a small startup company, Connectome Health, that one of my PhD students founded. And their idea is to basically track well, as a consumer service, basically provide a service for people to track their own cognitive data over time, basically
Hmm.
to am I am I am I getting neurodegenerative disease as I'm getting older, kind of thing, or various sort of things like that. And of course, one of the big things that we've had to look at is the ethics sort of side of this, and we're sort of running a trial, and the first all these questions being asked about um, data privacy, all of these things. It's very much um, is looked at in a way that I think sort of hasn't been for the AI industry more broadly. Of course, it just sort of directly interfaced with consumers in ways that were not, no one was checking the ethics of people signing up for Facebook in 2010 or whatever, right? And yet they've sort of, because of that, they've accumulated huge amounts of data which are of great value to them. Um,
Yeah, we're the product. We're not really the
and
customer.
we're the product, exactly. So I think there's a general awareness that we don't want to be the product for our medical data. We don't want to be the product for our cognitive data, our brain data. And actually, sort of coming back to that aspect, there's an organization called the Center for Neurotechnology and Law, um, based in the UK, but it's a sort of a worldwide thing organized by a barrister. It's a sort of a legal run thing, but they've come to sort of talk to various of us on the neurotechnology side.
Right.
And looking at that, there's someone from Chile who's on that panel. They've already actually affected the Chilean constitution, apparently, that there is um, um, a brain, basically there is a brain rights clause in the Chilean constitution now.
Wow, amazing.
So,
They
so
snuck,
this is
they just
actually,
happened to
yeah,
sneak that in there when they were
you have the right to control of your brain, to control your brain, the data recorded from your brain, which
good
so
call.
whether or not
Good call to do
constitutional
that. Yeah.
guarantees are required is maybe another story. But I think those kind of things, will sort of come out a lot more over the sort of in the coming decade. That basically people will be much more aware of what can go wrong if they surrender their data in a sense. Yeah.
Yeah, talking about how
Yeah.
privacy laws
Yeah.
and let's just look at privacy and cybercrime because these are things
Yep.
Philippines and has in common with the UK.
Yeah.
In
Yeah.
both of those cases, like I know the Data Privacy Act of the Philippines modeled after GDPR, and
Yeah. Yeah.
GDPR was, I mean, there's so many reasons, but one of the biggest ones is really the formation of that central marketplace or the common
Yeah.
marketplace
Yeah. Yeah. Exactly. Yeah.
necessitated a common understanding of something like
Yeah.
privacy, right? So
Yeah.
there was
That's right.
a pressure to
Yeah.
do that, and then
Yep.
the rest of the world just copycatted that in a good way.
Yeah. Yeah.
Cybercrime similar. I think there was something like a Budapest or Bucharest, I can't remember,
Yeah.
accord, where
Yep.
again, there was a general global agreement that for us to prosecute cyber
Yeah.
criminals, there has to be a common understanding of what a cybercrime is. So good.
Yeah. Sure. Yeah.
I'm trying to look for a similar structure for AI regulation, other
Yeah.
than it's nice to have, you know,
Yeah.
if you have a perspective on that. I mean, look, for example, we have Geneva protocols on
Yep.
biological weapons because we had a war and people didn't
Sure.
want to
Yeah.
kill
No,
that many
exactly.
people.
Yeah. Yeah.
So
It'd be
I don't
nice
know
to
what
get
the
ahead of the next one. Yeah.
yeah, I
Exactly.
don't know what the pressure would be for
Yeah.
AI other than these big Silicon Valley companies trying to monopolize things. I don't know what the pressure would be to fix it.
Yeah. Well, I mean, I guess we're seeing I mean, the pressure comes from seeing what goes, what can go wrong, and I think we're already seeing what can go wrong.
Yeah,
In the um, so I think that's where the pressure would come from. Um, I guess, another thing I want to say is I think these things do come with costs, or this
absolutely.
compromise comes with costs. And an
Yeah.
example I want to give, so as I said, neurotech regulation is still in its infancy, and so basically the various legislators are sort of grasping around trying to work it out. Um, so in so the EU have, a few years ago, passed a, I'm sure is it a law about some kind of requirement, that non-invasive brain stimulation. So basically, interventions in the brain can sort of fall under sort of different categories. Like medical devices, they have sort of different levels of severity.
Yeah.
And previously, non-invasive brain stimulation, by which I mean basically, these sort of things where you might sort of take the sort of magnet coil and use it to sort of stimulate the brain, and that's been, people are sort of working on this as maybe treatments for depression, or um, um, uh, ultimately some aims for things like treatments for Parkinson's disease, which don't require having an electrode implanted in the brain. So sort of a less invasive method of treatment for Parkinson's. Tourette's, another great example. There's basically treatments have been developed for Tourette's, based upon this. So sort of potentially very useful things. And they were considered to be a much less restrictive category than things which required, a piece of your hole to be drilled in your skull and an electrode
Surgery.
to be
Yeah.
sort of implanted in, right? You would think, obviously, that should be the most severe category. As of the moment, they're not. They're actually they've been put into the same category, although it's still working its way through, and I think
What?
it's going to couple of years before it sort of comes in. And I think this is based upon a bit of a misunderstanding from EU legislature of like what the potential effects are. And there've been sort of many papers written by sort of people working on non-invasive brain stimulation methods, saying this is crazy, that's going to stop sort of development of potentially groundbreaking new therapies, etc. You need to sort of pull it back a bit. So that's all sort of still, I guess, being worked out, and it will take a few years to sort of stabilize, I think. But potentially these things can hold things back unreasonably if they're not sort of done with understanding. So I'm not quite sure how these misunderstandings arose, but
No,
that's
I think it's
kind
a
of what can happen.
feature rather than
Yeah,
a
yeah,
bug. I mean,
yeah, yeah, yeah,
I encountered the
yeah,
same
yeah,
problem
yeah,
here. We're trying to
yeah,
lobby for a lot of
yeah,
policy
yeah,
reforms.
yeah, yeah,
I think there's a general observation, and I don't know if, let me know if you
yeah,
agree.
yeah,
The way policy people, quote unquote,
yeah,
work,
yeah,
they
yeah,
don't, they speak a slightly different language to academics and scientists and
yeah,
engineers.
yeah,
I mean, if you can lump all of the technologists, including scientists and engineers, in one
yeah,
category,
yeah,
they talk technology, they talk process, they talk
yeah,
data.
Yeah.
for policy, politics, legislation,
Yep.
you normally come off from a more normative standpoint. Like, what's the
Sure.
principle?
Yeah. Yeah. Yeah.
Which may or may not be supported by data. In fact, in many
Yeah.
cases, the laws
Yeah.
emerge in
Yeah.
environments where there's a dearth of data.
Yeah. Of course.
And
Yeah.
then the data comes in and shows how the law is wrong
Yeah.
eventually.
Sure. Yeah.
So
Yeah.
I mean, of course, it's not necessarily what we do or what you do, but how do we contend with that? Let's say in the case of AI, I mean, I don't know if there is enough
Yeah.
data. I mean, like for example, I'll use a lateral example, like social media, social
Yeah.
networks.
Yeah.
We've already seen what happened in Myanmar, genocide.
Yeah. Well, exactly. I mean,
I mean, how do
from
you how do you ignore
yeah.
that and not call a Geneva Protocol for social
Yeah.
media? I don't know,
Yeah.
out
I
loud.
mean, I mean, maybe we should be. I mean, on the other hand, clearly it doesn't mean banning social media because, you know, that's just not going to work, I think,
Right.
right? It's you'll just push the problem somewhere else. But yeah, I mean, so again, sort of regulating it. I mean, I don't think, can you imagine in 2005 or so, would anyone have predicted
Nope.
that abuses like that could happen as a result of this kind of social network? I mean, I think very few did.
We were too busy
Clearly,
poking
yeah,
each other. Remember there was that
exactly,
poke button.
exactly. Um, so I mean, clearly there have been some bad actors who maybe did foresee the ways that they could abuse the system, right? And
Right.
the other example is, I think there was a practice. Well, I mean, Brexit is one example, and before that, I think that there were attempts to influence election. I think it was a country in Africa that there was an attempt to influence an election as a practice run, even.
Yeah.
So this is and now that is, it's just a tool being used by all sides, as far as I can see. It's
Yeah.
well, I wouldn't say fair game, but it's just become part of the landscape. Um, and sadly, maybe that's inevitable. I mean, yeah,
Yeah, and then incidentally, the baddies seem to learn it faster
they do.
than the good
They
guys.
do
I think
seem
the same
to.
thing's gonna happen with AI,
Yeah, well, absolutely. Yeah, exactly. It's an arms race, but is it actually a fair arms race if one side's trying to do something and another side's just trying to stop something bad from happening? Yeah, exactly. There's
Right.
more ways to do bad things. Yeah. Um,
Yeah.
yeah,
No, I mean, given all of that, and
yeah,
just conscious of time as well,
yeah.
and we probably need a second episode. Well, where do you see
Yeah,
where do you see all of this going? I mean, obviously from where you sit in academia,
yeah,
neurotechnology.
yep,
I mean, sometimes we can just watch with horror at the train wreck happening in slow motion out there.
sure. Yeah,
But then occasionally we'll get an opportunity to give some advice. What would be your advice, and where
yeah.
would we be going with it?
So, well, but yeah, I mean, the first thing, maybe I could just say something about neurotechnology, because I think neurotech is right now maybe where AI was sort of 7 or 8 years ago.
Right.
In the sense there's a lot of excitement around it internationally right now. Yeah, maybe that excitement hasn't completely hit the Philippines yet, but it will. And in the US, Europe, China, absolutely, a lot of money being sort of thrown into various neurotech companies. Maybe in some cases, without very clear goals. I think some of the venture capital money is a bit credulous in my view, that people with money are surprisingly willing to kind of throw it on very slim um, evidential basis. So there's a lot of sort of things happening at the moment, and some of these are underpinned by good applications. So retinal prosthetics being sort of example of something that can maybe have a good business case, but actually have a good healthcare outcomes, etc. Other things like the Neuralink sort of
Hmm.
implants, etc. I think much longer term. I'm not. It's not clear to me that these things are going to be commercial in any or you know done for health reasons beyond the few initial trials anytime soon. Um, so I think it's there's a lot of developments that are going to be happening, some of which are going to be coming, through, you will maybe sort of see blind people that have had retinal prosthetic implants that can now see again, things like that.
Yeah.
Um, so some of these things will be coming through. Some of the things that you see in the newspapers sound like sci-fi are going to stay sci-fi for quite some time because they're actually really hard problems, and
Yeah.
there are all sorts of bits of it we haven't got a grasp on yet. Um, there are some of the things we hear about like merging of AI and human. I mean, the Elon Musk sort of thing. It's like, well, let's we'll put chips in your brain,
Transhumanism.
and then AI and humanity will merge. I mean that's a fantasy, right? Maybe in 100 years, but I think I think a lot of that stuff is a lot longer off. So I actually think AI is going to slow down a bit.
Okay.
um, I know it seems like it's just sort of accelerating off the, into orbit right now, but I don't think that that can be the case. So I think it's going to slow down, and we'll see more incremental advances in making things useful, in preventing hallucinations, in just doing useful things with it. And we'll see advances in neurotech, etc., in that time too. So yeah, I mean, I guess I would actually just say you can sit back and wait, because I don't think, it's not like you're going to come home next year and find out that um yeah, uh,
That Sky
Skynet has
Skynet has taken over.
Skynet has
Or,
emerged.
or maybe Skynet did take over. It's taking over
Would
art,
we even know? Yeah, exactly.
over
Um,
essays.
yeah, yeah. So yeah, exactly. I don't think anything drastic is going to happen on that front. Things will change, of course. They continually will change. There'll be things that we haven't thought about going to change. Um, but yeah, we're not going to have uh, AI becoming conscious
Yeah.
anytime soon, I think. Yeah,
And maybe even on the corporate front. I mean, I had this conversation literally just this morning.
yeah,
We've heard about we've heard the same pitch for every other
yeah,
IT trend in
yep,
the past. Big
yep,
data,
yeah,
CRM,
yeah, exactly.
and it's always adopt or perish.
Yep,
Adopt or perish. And I
yeah,
say I've seen companies and individuals who actually
yeah,
never adopted any of this stuff and they still be doing okay. I mean, they haven't perished.
yeah, exactly. Yeah. I
So
mean, they'll gradually adopt the things that turn out to be useful. I mean, being an early adopter is not always the right solution, right?
yeah.
Yeah.
And then there are technologies that end up being dead ends too, like
Yeah, absolutely. Yeah. Yeah.
I like my favorite example is did the UK ever have TiVo, so this thing that can record
Kind of. Yeah,
kind
but I
of.
think we were kind of not early adopters on it. So,
Yeah.
so
Yeah,
not that many
which
people
is
had it.
thankful, I think. But everyone thought
Yeah,
it was the
exactly.
bomb at that time. Like,
Yeah,
okay, I
that's
can
right.
record everything and then play it back, skip the
Yeah.
commercials,
Yeah.
only to find out that that's not really what people wanted. What people wanted
No,
is
that's
video
right.
on demand. And then when
Yeah,
that
exactly.
happened, TiVo
Yeah.
died.
I mean,
So that's always for me a cautionary tale. Anything
yeah.
that looks fancy and impressive, you're
Yeah.
always judging it by the standards of today.
Yeah,
Then the
exactly.
standards of tomorrow will be
No,
completely
that's
different,
right. Yeah.
you know.
Yep. Yep.
Okay.
I agree. Yeah.
Well, it's been great having you on the show, Simon. A really good chat. Obviously, we need to save some for the next run, but
Sure. Yeah,
yeah, and
absolutely.
maybe for people who want to get in touch with you, give a few
Yep.
details.
Yeah, yep. I'm happy to, yeah, give you
Yeah,
my details, and people can
yeah,
uh send queries if they want. That's absolutely fine. Yeah.
yeah. I mean the point is at
Yep.
least I mean a shout out to Angie who helped
Yep.
put this together.
Yeah.
uh Part of their intention was really to also start driving up interest in neurotech and neuroscience.
Yep.
I mean, we can't all be doing machine learning algorithms, right? I mean, there's got to be some other things to do. So maybe that's a good
Yeah.
adjacent
Yeah. I mean, machine
uh,
learning algorithms are going to be pretty pervasive, of course, and so they actually start to influence all sorts of other areas of science and technology, right? So yeah, it's what you do with them in the end.
yeah,
Yeah.
exactly.
Yeah.
Okay, so yeah, I hope to see you again in another chat, Simon. And yeah,
Yeah,
thanks again for
absolutely.
joining
Very
us.
happy to talk again. Okay. Bye. Thank you.